It's not showing up on my YouTube. Yeah, I do see actually two people who've joined. Hey guys, if you can see the stream, can you just comment something? Like just comment one or something. Okay, I think we're showing up now. Okay, Joy, you can
Cool.
take over.
Great. I'm going to start sharing my screen. All right. Hi, everyone. My name is Joy. I am on the cryptography team at Miston Labs. So I'm here to give a workshop on Nautilus. Really quickly on the agenda today, we're going to talk about like the goal, what problems Nautilus is solving, and as some of you may know, Nautilus is built on this existing technology called trusted execution environment, or some people call it enclave. So we're going to quickly go over that, and it will help you understand how Nautilus work. And I'll also talk about how what does an example application look like in the Nautilus framework, which involves an on-chain and off-chain component. And since we're here to help you with the hackathon project, I also want to do a deep dive into our documentation just to get you started. So there are many, we know that blockchain is very useful to do a lot of things. However, there are certain things you cannot do on blockchain. So for example, if you wanted to today, let's say we have a prediction market for a price of Bitcoin, to implement a prediction market on chain, you oftentimes need off-chain oracle about let's say the price of Bitcoin today, or let's say the weather, whether it rains or not today, or some sort of off-chain data, and you want to bring that on chain. And currently, the existing solution involves trusting someone to essentially post that data. And let's say if they did not post the correct oracle, you don't have a recourse in your, let's say your bet is placed in a prediction market. There are also times where doing on-chain computation can be expensive. For example, some trading applications, like low latency trading applications that are written in other languages, that are really hard to rewrite in a smart contract language, or even be possible to implement that on chain. And thirdly, there's also because the blockchain is a public, essentially public database. If you wanted to work with encrypted data in a state, for example, let's say like a poker game, it's very hard to kind of capture the game state somewhere on chain without ruining the game, essentially, because otherwise you can see the other person's hand. So with these kind of problems, we ask ourselves the question: how do we bring, if assuming that these computations that has to happen off chain, and it's probably the best solution to implement the off chain, can we use these computation result on chain somehow, and we still have the ability to trust them? So that's kind of the question that Nautilus tries to address here, is to bring off-chain computation on chain in a verifiable way. So very quickly, I want to mention what is a trusted execution environment, or people call it TE or enclave. It is a technology that is already exists in a lot of the hardware providers and also cloud providers. The most important thing about enclave is that it is an isolated computation environment. What that means that is the enclave binary that is running in a host instance, it has its own memory allocation, and no process on the host machine or anywhere else will have access to such memory. So you can presume, for example, you can encrypt certain data into an enclave, and then expect that only the enclave's private key can decrypt the content and then do certain computations over it. And then after a computation is done, it can return the result to the outside world. Another very important property is that Enclave does support remote attestation. What does that mean is that now that because the Enclave is a very secretive state and it does certain computation, how do we know that this Enclave is indeed doing the computation, let's say it does, for example, fetching the Bitcoin price from Coinbase.com? So in order to know that for sure, there is this concept of a remote attestation document. It is a document that is signed by an enclave that contains a unique measurement of the software that's running in the enclave. So you can think of this as some sort of receipt. Let's say I wrote an application saying fetch price from Coinbase.com today at noon, and return that result outside. And what a attestation document does is that it will do that computation and then provides like a stamp over the data, let's say the price of Bitcoin, and the code binary SHA, like hash of the binary that is running in the software. So as a user, you can actually look at the piece of code, let's say it's written in Rust, and then you can compile that code yourself, and it compiles the same binary hash that is the same as a receipt. So you, as a user who uses data, you essentially can verify the authenticity of the code that's running inside an enclave without needing to see everything inside the enclave. You just have this receipt and you have the cryptographic guarantee for something that happens. So we call this like a client. Client, anyone can verify the attestation. So how does this has anything to do with Nautilus? Essentially, the client here, we actually added such ability to verify attestation into the Sui blockchain. What that means is that you can take any attestation file generated from Enclave and bring that into Sui on-chain, and then you can verify that attestation. And currently, in particular, in Sui, we support AWS Nitro Enclave as a form of attestation document. The reason being, it is a very mature enclave technology, and they have all the necessary properties that we're looking for, such as reproducible build. So very quickly, how does Nautilus framework has anything to do with TEE or enclave? You can think of a Nautilus framework has two components. As we mentioned, you wanted to do some off-chain computation and then use that on-chain. So that's essentially the two components where you, as a admin, you can run your code in a trusted enclave environment off-chain somewhere, and it does certain computation. And then you can bring that such computation with a attestation file that is generated from the enclave, and you can actually write that in your smart contract where it can verify such attestation. So for example, taking the earlier example, if I wanted to use the Bitcoin price from Coinbase.com today at noon, I will write that in my application and then ask the user to fetch such result from the TE-based instance off-chain. And then once I get that data of a Bitcoin price and the receipt saying, hey, this is indeed the correct Oracle value that's being fetched at a certain time, and I'll take the receipt and the price and present it into, let's say, the prediction market smart contract. And the predictions market smart contract can look at the result and verify such receipt immediately, and then take the data for granted, saying, oh, the Bitcoin price I knew is indeed at this price. That is, the code is compiled correctly to such logic. So very quickly on how, like, if you today you want to build a Nautilus application, how does that work? An admin, let's say a developer, you can define a certain application, let's say in Rust, saying fetch the weather or fetch the Bitcoin price on Coinbase or what have you, and you can write such piece of software in any language you like. And then you can deploy Enclave into AWS EC2 instance. And once you finish the deploy, you can build the code into a certain hash. We call this measurement, or in AWS documentation form, it's called PCRs. And these are platform configuration registries. These are like unique identities essentially of your software. So let's say if I change fetch price from Coinbase.com to fetch price from Binance.com, the PCRs will actually change since they are essentially a one-to-one mapping of what your code is running. And as a developer, you can register such measurement on chain and its public key by fetching a attestation document from your enclave that has been running. And once you register such enclave, a user can actually interact with this enclave object on-chain by bringing the off-chain computation data on-chain. So what the user essentially can do is to interact with your off-chain enclave server somewhere and to process certain data, let's say fetch Bitcoin price. And once I get the Bitcoin price, I submit the data on-chain along with the receipt, which the smart contract can take for granted that this is the data I trust computed by the enclave with the certain measurement. So a little more in details on the various components of an enclave. So as mentioned earlier, the admin here essentially can publish the code somewhere, let's say GitHub, and register the PCRs, or we call it like measurements on chain, and then put them into a smart contract. Let's say it's called a registry. And this registry contains all the configurations of the off-chain code. It maps essentially to the binaries that is running off-chain somewhere. And it also generates a attestation document containing a public key. So we have a public key that's committed. Essentially, it's a mapping between the public key and the code measurement called PCRs. And now that I have an enclave running, like inside a AWS EC2 instance, in this box here, we can see that the enclave can expose the endpoint saying process data. And the process data will return some data to the user. So how does a dApp user interact with a Nautilus application? It first can optionally verify that the code essentially matches what I see. So essentially, I can go on to the open source GitHub page and look at the code, let's say fetches Bitcoin price from Coinbase.com, and then compares that the PCRs, the measurements of such code, build identically to the code that is basically registered on chain. So if they matches, I have as a user, I have certain confidence that this instance I'm interacting with is indeed the code I see is indeed the one registered on chain. So once I enter, now I have such confidence between these three components, I can talk to I can talk to the enclave instance to process certain data. And then the response came back with a receipt saying, hey, this is the data being processed, and here's the proof. As a user, now I can go into any dApp application, let's say do something, maybe make, if the Bitcoin price hit a certain price, then I will give you your bet back on the prediction market. Then I can implement my dApp logic as whatever I want. And all you need to do is to add a block here where it takes in the enclave object and verify the receipt before you use the data. So the response here, let's say, is the Bitcoin price. So all I need to do is to verify that this receipt is valid, and then later use the Bitcoin price in my contract. So now let's talk about how to build with Nautilus. So we provided this documentation page. If you go on to sui.io/Nautilus, you will be able to find it. There are essentially three very high-level steps um, on how to build with Nautilus. The very first step is that you will deploy your enclave off-chain code somewhere in your AWS EC2 instance, and we actually provided a template that gives you all the scaffoldings to kind of handle enclave, since there are a few gotchas around how to run an application inside an enclave. For example, there isn't internet access, so you need to manually forward the traffic, let's say from outside the internet to fetch certain data. And we provide such template for doing all these scaffolding code around it, so you can actually just focus on implementing your own process data endpoint. It could be fetching Bitcoin data, it could be fetching weather data, or any or running an AI agent or any off-chain logic you would like to implement. And secondly, how do you link your off-chain application with the on-chain artifact? What you can do is that you take the server measurements that the enclave instance returns you and its public key. You then take these data and then register the data on-chain. Once you're registered on-chain, your application is all ready to use. You have your off-chain component and your on-chain component. So now the next step will be writing your actual dApp that verifies the off-chain data and then use it on-chain. So in the form of the Bitcoin price, you can take the enclave object and verify the Bitcoin price that is part of the receipt, and then you can start using the data on-chain. So now I want to spend 10 minutes just to going through the documentation that you can find on the sui.io/Nautilus. This is a very complete guide on covering all the steps that needed to build example application. So as we mentioned earlier, there are a few components where you have to deploy the off-chain code and then the smart contract, and then your dApp to use the Nautilus application. And as we mentioned earlier, that Enclave does not come with internet access by itself. So we built this template that would essentially help you to allow list HTTP domains that your enclave needs access to. For example, let's say Coinbase.com is something you need to fetch press from, then you have to whitelist through this configuration file. And we also had a few template codes around how to configure the EC2 instance and allocates enough space for a Nitro Enclave application, and how do you compile the application into the Enclave format, which is possible to run in an Enclave that can actually give you the guarantee that no one else can have access to such isolated Enclave environment. The Enclave has 3 endpoints that is in a template. The first 2 endpoints are actually part of the template that you do not need to modify. The first one is health check, which is straightforward, and the get attestation endpoint is actually what's needed when you're registering your enclave. It essentially generates under the hood an ephemeral key pair inside the enclave, and the private key never leaves the enclave, whereas the public key is being produced into a attestation document that can prove to you that only this enclave has access to the private key of such public key. And lastly, the part that you as a developer should focus on is this process data endpoint. In this particular example, we implement application-specific logic to fetch weather data from external API. And let's say you can actually change such like setup into anything else. And let's say running an AI agent or fetching Bitcoin price data or anything. But the point is that the process data response always contains a receipt signed with this ephemeral private key that only lives inside the enclave. So the code structure, it's quite straightforward as well. We separated them into different applications where you can find certain examples that is needed to be changed for your application. So there are, as mentioned, there are two components here where, for example, the weather example, there is a template move code where you can find in the move directory. And then you can also find the template Rust code inside the Rust directory. And they go hand in hand to run inside the enclave as an off-chain application and on-chain as the verifiable part where you can actually use the result. So to recap, what you need to do as a developer is that you first would like to build the Rust server logic, and secondly, you want to build your on-chain move modules, and then thirdly, you can then start using your move contract dApp to implement any front-end logic to interact with the smart contract, and the rest of it should just happen in the background, and it should be pretty easy to use them without modifying it. We have a script around how to register Enclave by using the attestation document. As long as you do not change the get attestation endpoint, you don't have to worry about the whole on-chain registration workflow completely.
Joy, there's one question. I'm sorry. Do you want to complete before answering the question?
Sure, I can take the question.
Okay, so the question is, can you explain how the receipt from off-chain computation verified on SWI? Again, it's on the screen.
Hold on.
Are you
Oh, I can see it. How the receipt from right, yeah. So what I guess the receipt here is actually the remote attestation document. You can think of it as it is a attestation document that the AWS Enclave technology provides that is signed over the code hash along with this public key. So what this attestation can be verified is that here's a attestation file, and I can show you that this enclave being registered indeed has a certain measurement PCRs and also the public keys. So you can think of it as an identifier for a certain enclave. Does that make sense?
Yeah, I can just monitor the comments if a follow-up comes up.
Cool.
Thanks.
Sounds good. Yeah, there's also a lot of nitty-gritties I can go into what is AWS Nitro attestation document. If you like to search for attestation document AWS Nitro, it can actually give you a full breakdown of what actually is inside the attestation document. But in general, you can think of it as a signature from AWS root certificate that is signed over the PCRs and the public key that is part of what your application give it to. Cool. So I guess that kind of covers like everything I want to mention. I won't go into detail on like how exactly to deploy all the servers. I think if you follow along with this guide on my screen that's also linked, you should be able to kind of follow through the whole flow and deploy an example application. Right, and then the next thing I want to cover is to essentially give you an idea of what is possible to build with Nautilus. These are just very few categories I want to mention since um, building an application off chain is there's so many possibilities, and as long as you see a use case to for some data that you either do not want to or have a very particular reason you cannot implement them on chain, you can always implement it with Nautilus and then continue your application on chain and just delegate this off chain computation somewhere else. So, one thing I mentioned earlier is about trusted oracles. You can have the enclave to process off chain data from a Web2 server. And there are reasons that this has to stay off chain. Let's say you will need API keys to fetch such things, and it's not possible to, let's say, post your API key somewhere in public. And secondly, you can build AI models, AI agents where heavy computations are required, or let's say your model is running in Python or some other computation environments that it just simply cannot do on chain. So you can actually have AI agents running, and then you can use the outcome in your on-chain application. And thirdly, you can also build confidential computations inside Enclave. Since we mentioned that Enclave comes with a private key that no one else can have access to, it has in an isolated environment. You can actually take the public key and encrypt sensitive data into the encrypted state. Let's say you can even have, let's say, some KYC data being processed by Enclave, and you're able to use the KYC result on chain. Let's say, like, are you above? Someone can submit like a driver's license encrypted under the public key, and the Enclave can decrypt it and figure out the age, and then can return a yes or no if the person is above 21. So, just to give you an idea of how how powerful Nautilus framework is, you really can implement everything else. And a bonus point is that I encourage you to think about is how does Nautilus can be combined with Seal. So Seal is our decentralized secret management framework. And you can imagine I can define a Seal policy where only an enclave can have access to a certain secret. And we actually provide a template in our example as well on how to do this more specifically. And for future questions, we also have a Discord channel just called Nautilus in the Sui Discord server. And feel free to follow up with any question there. But in the meantime, free to take any questions here as well. Cool. I think there's no questions. Well, feel free to ask us offline as well in the Discord.
Yeah, I think we can. Okay, I guess one
Oh.
question just showed up.
Great. What are the example applications that has combination of Nautilus and Seal? Currently, there are a few teams has been working in this direction on their applications. So the very simple use case, to give you an example, is that let's say in my weather fetching Nautilus application, I actually have an API key for weather.com, for example, that I want the enclave, I want a Nautilus server to have access to. And if you're familiar with Seal, in Seal, you can define a certain access policy for a secret in Move. So you can actually look at Seal CO policy and then define it with the enclave object, you will end up with you can actually define a secret that is only accessible by the enclave. So what does the workflow look like is that I have an API key for weather.com. I can encrypt it with CO's public key anywhere I want to, and I define a CO policy that says only the enclave have access to it. And then I gave such encrypted result from CO. I provision it into an enclave instance, and I can be guaranteed that only the enclave can decrypt such API key. So if you were to go to the repo here, we have a work in progress example here called in the apps. There's a CO example, and there's a README. Essentially, this is doing exactly what I just mentioned. You can store the weather API key with CO instead. Streaming platforms like Spotify Live, Unsweet, and Walrus. Yeah, I think that's a great use case for Walrus and also CO as well, where you can define access control to it.
Okay, I think we can end the stream. Guys, if you have any questions, like Joy said, feel free to hop onto the Discord. Joy and all the other engineers on the team are pretty active there, so I don't think you'll have to wait for long to get answers to any specific end-related questions. Thank you so much, Joy.
Thank you. Thank everyone for tuning in.